So remember when we're working with perimeter, we're basically talking about, what that total distance will be around the shape, if you go around. So like I was mentioning last time, think about if you were going to put a fence around a, rectangular yard or a garden or something like that. When we are talking about an area, this is where you are covering the entire surface. So think about, laying down a carpet or painting a wall because, you cover the entire surface. So that's where we're talking about the area. So, they had given us these basic formulas here for the different shapes: triangle, rectangle, parallelogram, trapezoid. So based on this, let's pick an example from our section 8.1 first. And then, like I said, we'll look at the last part of 8.1 and then get into 8.2. So we'll look at number 24 over here. This one is telling us a rectangular swimming pool, which is 30 feet by 15 feet, is surrounded by a uniform concrete sidewalk, which is 5 feet wide. They're telling us the pool is positioned inside a fenced-in circular grassy region, which has a diameter of 60 feet. So the first thing they're asking us to do is find the surface area of the water. Then they are asking us to find the area of the concrete sidewalk. And then the last part is area of the grass. So we will have to wait for area of the grass because, of course, we haven't talked about the circular shape yet, but, we can go ahead and do the first two parts and then we'll come back and talk about, the area for the grass. So let's start with part A, which is talking about the surface area of the water. So any ideas on where or how we can calculate the surface area for the water here?
$30 times 15.
Yeah, because they're telling you that the the swimming pool is basically 30 by 15 feet. So that's of course going to be your basically the area for your pool, which is of course completely filled with water. Alrighty, very good. So the surface area for here will be 30 feet by 15 feet. And remember, this is where we had talked about that two-dimensional measurement for area. So let's see, 15 times 3 is what, 45? So this should be 450. And then area is always going to be square feet, right? So make sure you have that right unit of measurement. All righty, perfect. What do you think we would need to do to find the area of the concrete sidewalk, which is what you're kind of seeing in that lighter yellow color in your diagram here? Because they're telling you that the sidewalk is 5 feet wide, right? So if it's 5 feet wide, how will we go about calculating the area for that concrete sidewalk?
Add 10 feet to each side.
At 10 feet to each side? Okay. What do you guys think? Do you agree with that? Would you change something? Roman, Nicholas, Brandon? So think about this. They're telling you that the pool itself is 30 feet by 15 feet, right? And then they're telling you the width of the sidewalk is going to be additional 5 feet, which means you will have 5 feet here, 5 feet here, right? 5 over here and 5 over here. So yeah, as you can see on the length side, you've got 30 horizontally, but then you're adding 5 over here and 5 over here, which will make that 40 on the width side where you have the 15 feet. Again, you're adding 5 feet over here and 5 feet over here. So that will make it 25. So is that all we need to do is just multiply 40 with 25? to get the area of our concrete sidewalk?
You got to subtract the area of the pool after all that.
Yeah, very nice, Roman. So yeah, because obviously the concrete sidewalk is not covering on top of the pool. You are doing that only on the, the surrounding. So you get 1,000 when we multiply 40 times 25, so 1,000 square feet. And then from that, like Roman said, go ahead and subtract 450 for the water surface area. And what are we looking at as our concrete sidewalk area in this case?
$550.
550, yeah, very nice. So, and of course, we are still talking area, so it is still going to be in square feet. So this is for the surface area of the pool, and this will be for the concrete sidewalk. All righty, perfect. So let's go ahead and save this. And like I said, I did want to talk about the circle before we came back and looked at option 3 over here, or part C, I guess. Come on. Okay. I had also mentioned that we have this different formula for the area of a triangle. And this happens when, they're not giving you the perpendicular height, in your triangle. So if they only give you the 3 sides of your triangle, then basically using that, we have to calculate what our area is going to be. So that's where the Heron's formula comes into play. You guys will also be familiar with the right angled triangles or right triangle, where, as I had mentioned last time, again, one of your angles is going to be 90 degrees. And that's what makes it a right angled triangle. So the side that is opposite to that 90-degree angle is what we call as the hypotenuse. So you can see that's going to be this side over here. And then the 2 other sides are what we call as legs. So the side across from the 90-degree is the hypotenuse, which will also be the longest side for this triangle. And then the 2 shorter sides are what we call as legs. And, using the Pythagorean theorem or Pythagorean formula, if you know any of the 2 sides, you are able to calculate the 3rd side. So that formula is c squared, which is for your hypotenuse, equals a squared plus b squared, which are going to be your 2 legs. So if you know any 2 of those values, you can calculate the 3rd missing one. So, this is all coming from our triangles. Now, when you're getting into circles, of course, when we're talking about a circle, we're basically saying it's a set of points in a plane which are going to be equidistant or equal distant from a fixed point. So your fixed point is going to be the center. And the idea is that same distance, will give you, if you go around, will give you the circle. And, of course, that fixed distance is what we call as the radius. So if you're going from the center to the edge of your circle, that's your radius. If you go from one end of your circle to the other, when you're passing through the center, that gives you your diameter. So when we are talking about area and perimeter in terms of a circle, of course, we use the term circumference when we are talking about, the perimeter. Okay, Brandon, I see your answer there. So when you're talking about the perimeter for a circle, you're talking about the circumference. And, they're just kind of showing you in terms of, if you look at the circumference over here, they're trying to show you that it's going to be 3 times the length of the diameter, if you lay it out horizontally. And then your circumference will be slightly larger than 3 times that diameter. So here's your formula for the circumference of a circle. So again, remember, that's the perimeter basically, and that's C equals 2 pi r. R, of course, is going to be the measurement for your radius. Pi is the factor of, as a fraction, we write pi as 22/7. As a decimal approximation, we write pi as 3.14. And a lot of times I just say use the pi key on your calculator to do the calculations instead of typing in an approximation. Most of your scientific and calculators will have the pi key on them, and that's what I would recommend using. For the area of a circle, we of course have the formula A equals pi r squared. So again, that r is going to be, the radius. So using that, which is what Brandon was giving us as the answer, when you try to find the area of the grass, again, we have to think about just the green area, not including the concrete sidewalk and the pool. So we had, let's see, 450 square feet for our surface area for the water. We had 550 for the concrete sidewalk. So now to calculate the area of the grass, of course, they are telling you that the fenced in circular grassy area has a diameter of 60 feet. So using that, we can plug that into our area formula. So that's pi r squared. So what do you think the radius will be if the diameter is 60 feet? No, yeah, because Brendan, I just saw your answer. Yeah, because if you have 60 feet as the diameter, then, of course, diameter is twice the radius. So all you would do is divide that 60 by 2, and your radius would come out to be, if it would let me, right. Okay. So the radius is diameter divided by 2. Which would give us the 30 feet. So, like I said, just use the pi key on your calculator. So you're just doing, pi times 30 squared. And let's see, Brendan, you had the answer. Okay. There we go. So will this be the area for the grassy region of our, what is this, fenced in yard or whatever this is?
No, you have to subtract the area of the pool and sidewalk.
Yeah, so you have to subtract the area of the pool and the sidewalk to just get the area which is in green, that's the grassy part over here. And they didn't really tell us how many units to round it to. So for now, we'll just round it to 2 decimal places, and then you can fix your answer based on your homework. So remember, your total area for the water and the sidewalk was coming out to be 1,000 if you just add these guys together. So subtract that 1,000 from this, and that will give you the area of the grassy region, which, of course, 2,000 minus 1,000 will give us 1,827.43 square feet. So that's the one thing you will need to remember is, making that little adjustment to your area, because, obviously you have to remove the pool, this concrete sidewalk. When you calculated the area for the concrete sidewalk, you had to remove the area of the pool. So just make sure you remember those calculations as you, come across examples like this. Did anybody have a question on this? Okay. Let's see if we can pick something with Heron's formula over here. Okay, so they're asking us to find the area and the perimeter. So let's pick a 90-degree triangle, a right triangle, and one of these non, 90-degree ones. So let's start with number 12, and then we'll do number 14 next. So they're asking us for area and perimeter. So where should we start? Looking at number 12, you've got the hypotenuse, which is given to us as 5 kilometers, and the one of the legs is given to us as 4 kilometers. So what's the first thing we'll need to do here? Okay, Brendan, you're talking about using the area formula, base times height divided by 2. So which one will be our base and which one will be the height? Because again, remember, we're looking at number 12 over here.
We need to find the value for the perpendicular height.
Yeah, so actually before we can get to the area or the perimeter, we would actually need to find the third side, because when you're looking at the triangle, and I'm just going to sit that triangle the right way. So this is 5 kilometers here. This is our 90-degree angle. This is 4 kilometers. So what happens with the right triangle? One of the legs will actually form the height and the other leg will form the base for your triangle. So since this side is missing, we need to find that side first. So this is actually where your Pythagorean theorem comes into play. So remember, that is c squared equals a squared plus b squared. We know the c squared is going to be for the hypotenuse, but it honestly doesn't matter where you place the a and the b, you can place it anywhere. So our c value will come out to be 5 kilometers, so that's 5 squared. In our case, a is missing and b is given to us as 4 kilometers, so that's your 4 squared. And then based on that, we can go ahead and calculate the value of a. So 5 squared would give us 25. 4 squared, of course, is 16. To get a squared by itself, we subtract by 16, get a squared by itself. And what will your a value come out to be? Okay, Brandon. See, so this will cancel out here. Yeah, very good. So if your 25 minus 16 will give you 9, to get a by itself, you basically end up taking a square root. Now, just to remind you, normally when you take a square root on any number, it actually gives you one positive and one negative answer. And that's a standard thing that happens anytime you are working with square roots. So anytime you take a square root on a number, you will get a positive and a negative answer. But of course, what happens in this case is, since you are trying to find the side of a triangle, we know that the side of a triangle cannot be a negative number. And so that's why we can say, okay, in this case, we need to discard the negative answer, because my triangle cannot be negative. So you will end up getting a equals positive 3. So we've got our 3 kilometers for the other side. So now can you tell me what the area for our triangle will be here? So do your math and then let me see what all of you get as an answer for this guy. Okay, go ahead and share your answer with me, please. Yeah, very good, because you are taking 1/2 And then, like I said, you can think of this as being the height of your triangle. This is being the base. So that would be, 3 times 4. But then again, 2 goes into itself 1 times, 2 can go into 4 twice, 3 times 2 will give us 6. And yes, since this is an area, Logan, you had that answer. This will be square kilometers for your unit. Perfect. And then what perimeter are we looking at here for this triangle? Yeah, Logan, I was about to say you're short 1 kilometer there. Yeah, 3 plus 4 is 7. 7 plus 5 is 12 kilometers. So 3, 4, and 5, add those together, you will get a total of 12 kilometers. So, again, you got to see how to use the Pythagorean theorem in this example, and then using the traditional area formula for a triangle, we were able to calculate the area, and then of course perimeter is adding all 3 sides. Now let's take a look at what to do when you don't have that perpendicular distance given. So how would we calculate the area and perimeter? Well, perimeter will stay the same, but how do you calculate the area? So for this one, we will look at number 14, and again we need the area and the perimeter. So this is where, your Heron's formula will come into play. So let's take a look at it really quickly. So there's 2 parts actually to this formula here. So one thing we have to do is calculate this S value, and they're kind of calling it like the super perimeter. And as you can see in the description over here, they're saying when the lengths of all 3 sides are known, the super perimeter can be used to find the area. As the name implies, this semi perimeter, man, I can't read. Semi perimeter is actually half of the perimeter. So you will see how they are adding A, B, and C over here, and then they take its half. So that's your semi perimeter. And then we have to use that value of the semi perimeter in our area formula to calculate the area. So let's start actually by calculating our perimeter, since we already need that to calculate the semi perimeter. So can you tell me what our perimeter for this triangle will look like? Yeah, very nice. Perfect. So 9 plus 9 plus 6 will give us 24 centimeters. And then, we can calculate our semi perimeter. So 1/2 times the perimeter, will give us 12 centimeters. So we've got our perimeter and our semi-perimeter. Now for the formula for the area, this is going to be square root of S times S minus A, S minus B, S minus C. And again, you can see that here in your handout. So this will be square root. S is 12. Then you are doing 12 minus, and I guess it really doesn't matter, but we'll go ahead and label these guys. So 12 minus 9, 12 minus 9 again, and then 12 minus 6. So I'll give you guys a couple seconds to calculate that, and let's see what your answer for the perimeter comes out to be. Area comes out to be. Okay, if you have your answer ready, go ahead and share it with me. Very good. Yes. So I see Brandon, Logan, Roman. Yeah. So, multiply the numbers and, you can see I put the subtracted values in there. And then you're basically taking square root on that. So I think it came out to be, let me see. When you just multiplied the numbers, we got 648. And then you're taking the square root on that, which is where you get the 25.4558. So when you round it, and yeah, again, you can do 2 decimal places for now, and then you can see what your instructions are in homework. So 25.46, and since this is area, it will be square centimeters. All right, perfect, guys. Good job. So that's your Heron's formula, something a little bit different. And, I'm not sure if that is a formula you see in other classes or not. I know we talk about it in our trigonometry class, but I'm not sure where else you might see that. I know we don't see that in algebra. Another thing I would say is just practice with some of these other shapes to get a little bit of a practice. You know what? Let's do an example on a trapezoid just to get you comfortable with the formula for a trapezoid. So let's look at number 8 over here. Let's see, what are the instructions? Is it area? Find the area, round off to 1 decimal place. Okay. So they're asking us to find the area of this trapezoid. And again, just to show you the formula for that trapezoid, right over here, you will see it's 1/2, then in parentheses, base 1 plus base 2, and then multiplying by h. So it's still technically 1/2 base times height, but the difference is for the base in a trapezoid, you're having to add base 1 and base 2. So you can see base 1 and base 2 are going to be these, lines that are parallel to each other. And then your horizontal, vertical perpendicular distance between the two bases makes up your height. We don't need this here. Okay, so 1/2 base 1 plus base 2 times height. All right, yeah, Brandon, I see you're just using A and B for your bases, but yeah, add the 2 bases, divide by 2, and then multiply by the height. So in this case, of course, we've got 1/2, and then your base 1, you can think of this side. The longer side, you can think of that as your base 2, and then, of course, this guy becomes your perpendicular distance, which is the height. So add, again, you're using order of operations here, guys. So do the addition part first inside the parentheses, and then we'll do all the multiplications. So go ahead, get your answer ready, and then let's see what you guys come up with for the area of this trapezoid. Okay, so if you're ready, go ahead and share your answer, please. All righty. Oops, didn't mean to do that. So 1/2 here, and then 4 and 12 will be 16, so 160, and then, multiply that by 30, which again, if you wanted to reduce it, you can take 2 goes into itself once, will go into 30, 15 times. And then you're just multiplying 160 with 15, or, of course, just use your calculator. And let's see, I have Brendan, Logan. Yeah, and again, since this is area, this will be a square feet unit on this. Alrighty, perfect. Okay, so that is your section, 8.1. So they basically get into those perimeter area questions. And, we looked at some of the more challenging ones here. You will have some basic examples on just calculating the perimeter and the area for some of those basic shapes. So, kind of like the examples you're seeing here at the beginning. So just some of the practice ones. Okay, now when you get into section 8.2, this is where we're actually getting into a little bit more, three-dimensional. So here we're talking about the volume, and volume is basically what would be the amount of space occupied by a three-dimensional object. So you can see that right over here, the first line. So they're saying the fundamental figure used in calculation for the volume is a cube. They're saying the volume is expressed in terms of cubic units, right? So to the third power. So cubic units can be cubic feet, cubic centimeters. So just like we saw with this rectangle over here, we were trying to see how many of these tiny squares can we fit inside of a rectangle, and that would give us the area of that rectangle. We actually use the same idea with volume. And I don't know if they have an illustration over here. They don't. But, the idea is how many of these 1 by 1 by 1 cubic, cube can you fit inside a rectangular box like this? So, the idea would be how many of these would we need to stack inside a box to calculate your volume. So you're kind of thinking in those terms. So volume, since it's three-dimensional, the way you calculate your volume is, length times width times height. So you can think of this as your length, your width, and your height. So you multiply all three of those dimensions together and you get the volume of, a rectangular object, something which is a square, of course, that would be your cube, or a rectangular box. Now, as you get into other shapes, it's going to change a little bit. So in this one here, they're talking about if you have a three-dimensional figure that has a height h and identical cross sections from top to bottom, which means, the shape of your object is going to stay the same from one side to the other. It's not going to change shapes on you. Then they are saying basically in this case, each of the area and the volume of the figure is going to be based on the idea of, you look at the bottom part, and remember this is where your shape is staying the same from top to bottom. So you basically find the area of the bottom, multiply that by the height, and you will get the volume of that object. So here they're talking about, surface area, which is basically what you are doing here at the bottom, where you take the area of the bottom surface, that's your surface area. They're saying, of course, with the surface area, also, if you're looking at a three-dimensional figure, we are also talking about the sum of the total areas of all the surfaces. So in this case, if you were looking at the rectangular box, you would basically take the area of each of the faces of the rectangular box. So, we would be taking the surface area of this face here, this one here, this one on the top, the one on the side, the one on the bottom, and, of course, the one on the back. So you can see we will end up having 6 different faces on this rectangular box. So you add all of those surface areas together, which gives you the surface area of the three-dimensional object. So they're saying, although a formula for the surface area of the rectangular box could be given, it is not necessary because we already know how to find the area of a rectangular face, right? So if you know how to find the area of just one side you will be able to calculate the surface area for the rectangular box. Now for non-rectangular objects, they are saying, that will take a little bit more of a calculation. So in those cases, we would actually get into a little bit more on a calculus-based calculation to calculate the surface areas, especially like this shape you are seeing over here, as the tools we have right now, we wouldn't be able to calculate the surface area for an object like this one. Of course, for cylinders and spheres, we do have formulas that we can use. So let's take a look at a sphere over here. So again, think of a ball. You have your center for that sphere. Now, as you go from the center to the edge of the ball or the sphere, again, that will calculate as your radius. Your diameters, you're still thinking in terms of how we did with the circle. You go from one end of the ball to the other, opposite end, and you have to pass through the center, and that would create your diameter for the sphere. So when we are talking about the volume for a sphere, you are looking at this formula over here. And remember, these are in cubic units, so to the third power. And you can see, since we have the radius multiplied into itself 3 times, that's where you will get those cubic measurements from. For the area, you are looking at the formula 4 times pi r square. And of course, area is still going to be in the terms of square units. So volume is going to be in cubes, area is going to be in squares. So let's do an example on the sphere, and then we'll come and look at some of the other shapes. Didn't need to do that. 8.2. Okay, so you can see we have some general basic shapes over here, but let's see if we can find. Okay, they're getting into phones. Yeah, I think this is the example I've used before. So this one looks good. Let's take a look at number 22 over here. So they're telling us the diameter of the Earth is approximately 7,920 miles. And then they're telling us the diameter of the planet Jupiter, which is the largest planet in our solar system, is approximately 88,640 miles. So they want to know how many Earths can we fit inside of the Jupiter. And of course, you can see the hint. They're telling us to compare their volumes. So let's start by finding the volume of the Earth, and I'll actually transfer this example to our notebook over here. Okay, this is number 22. Okay, so again, for the volume of a sphere, we are looking at 4/3 pi r cubed, right? So 4/3 pi r cubed, and we need to know what is the radius of Earth. So what would you say the radius of Earth is? If they're telling you the diameter is approximately 7,920. Yeah, Brandon, very good. Because, you're still using that same idea that, if the diameter, the radius is basically going to be half of the diameter. So we will take our 7,920 divide by 2, and Brandon, that looks good. Okay, so then using that, we can find the volume, which will be 4/3 times pi times our radius of 3,960 miles raised to the third power. And I'll definitely put all of this in the calculator so that it can, do the calculation for us. And because you are taking that 3,960 to the third power, I would imagine your calculator is probably going to give you answers in scientific notation. Okay, can you share with me what you are seeing on your calculator? And we'll have to clean it up a little bit because like I said, by default, your calculator is going to give you scientific notation. All right, Logan, you've got 2.60120253 times 10 to the power of 11. Okay, yeah. So 2 point, and I think my calculator just gave me one extra decimal place. So 601,202, 526. So since you have 10 to the 11th power and that 11 is a positive number, that actually means you are moving your decimal place 11 places to the right. So, if you go from here, you're going 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we have to add 2 more after that. So when we correct this, you end up with 2601. 202, 526, and then since we had 2 more decimal places, that means we're putting in 2 more zeros. So then you can kind of see what this number comes out to be. So that's what, trillions? 260, 120, well, 260 trillions, 120 billions. Sorry, no, I went too far, didn't I? 260 billions, 120 millions, 252,600. And then remember, this is volume. So you are looking at cubic miles, or, you can just write it out as cubic miles. So that is the volume of Earth. Now we have to see what would be the volume of Jupiter. And then, we will be able to figure out how many Earths can we even put inside of a Jupiter. Okay, so same formula, 4/3 pi r to the third. And in this case, for Jupiter, the diameter is approximately 88,640. So same thing, like you did for Earth, divide that by 2 to get your radius. Yeah, Brendan, very nice. So you will get 44,320 as our radius. So when you put this into the formula again, and as you can imagine, again, this answer will come out to be fairly large. So this guy is coming out to be 3.64 659,779. Yeah, and this one is 10 to the 14th power. Very nice. So obviously that means you are now moving your decimal 14 places to the right. So that would be 1, 2, 3, 4, 5, 6, 7, 8, and then 9, 10, 11, 12, 13, 14. So how many extra zeros is that? 1, 2, 3, 4, 5, 6. You can see then this guy is coming out to be 3, 6, 4, 6, 5, 9, 7, 7, 9, followed by 6 zeros. Okay, this one goes into trillion. So 364 trillion, 659 billion, 779 million cubic miles. So that's the volume. For Jupiter. So now that you have the two volumes for the Jupiter and the Earth, what do we need to do next to figure out how many Earths can we put inside of a Jupiter?
Divide?
Yeah, you will need to divide the volume of Jupiter by the volume of Earth in this case. Okay, so let's see, what did we have for this guy here? Okay, and I see you have shared an answer. Just give me a second here. What do we have for you? 260, 120. $252, 600. Oh, come on, buddy. Alrighty, Brendan, very good. So you have 1,401.889, and it kind of keeps going. So let me ask you, would we round up or would we round down in this example? Since we're talking about, fitting the Earths inside of a planet Jupiter.
Down.
Yeah, you have to round down because, even though you are going to 0.8894, you of course don't have room to get a 1402 Earths in there, right? Because, obviously, you will not be able to get an entire Earth. You can only get 0.889224. So you round down and we will say approximately 14.01. Alrighty, guys. Any questions on this example here? Okay. Um, Let's just do a quick example on surface area so you get a little bit of practice with the surface area also. So for this one, we will just calculate the surface area. So again, for surface area, your formula is 4 pi r squared. Okay. So let's start by talking about what will be the radius in this case if the diameter is 2 3/8. And you can convert it to a decimal if that makes it easier. Yeah, very nice, Brendan. So you're basically 2 3/8, will come out to be 2.375. And then, again, divide that by 2, and you will end up getting 1.1875, and this was in inches. Okay, so then we are doing 4 times pi times 1.1875 to the second power. And what are we looking at as the surface area for this guy? And again, guys, anytime we are talking about area, you are talking in terms of square units. So this will be in terms of square inches. Anyone have questions on this? Nicholas, are you doing okay? Yeah, okay. Okay, so that was our sphere. Now, the other shape that we want to discuss is, cones and pyramids. So it really is just a difference of what the bottom of this shape will look like. So, when you're talking about a cone, you basically have a circular base, which is what we have over here. So that's a circular base on a cone. When we're talking about a pyramid, you will have a polygon. So that basically means you can technically have a rectangular base or a square base. When they use the term polygon, they're basically saying it can be any one of those many-sided shapes. But, for the most part, I believe the examples we'll be looking at, you will have squares or rectangles as the base for a pyramid. But, technically you can have some more bases on that bottom. So as you can see over here, we're talking about finding the volume of a cone or a pyramid as 1/3 times area times height. So the idea is you are finding the area of, whatever that base of your cone or pyramid is going to be, and then, multiply that by the height, and then a factor of, 1/3. So that's how we're calculating the volume of a cone or a pyramid. So let's take a look at an example with that. And I know we have something over here. Want to pick something a little bit simple for the first example, and then maybe get into those other ones. I guess we'll just do one of these over here. Well, not very exciting, but they will at least get us a starting point. So let's start with the cone over here first. So of course, remember for a cone, you have a circular base on the bottom. So the first thing we would have to do is find the area of the base. And in this case, you can again see they are giving us the diameter. So you are starting out by actually finding the area of a circle. And, you know, of course, that formula will come from 8.1 section where we just got done talking about circles. So you are first using this formula here. Area of a circle is pi r square. So using that, can you tell me what the area of our base will be here? Brandon, is that your number for the area?
Yeah, because it would be pi 6 squared, right? Because you got to get the radius from 12. But I just rounded it.
Okay,
yeah,
okay.
correct.
I see what you did. Okay. So let's see. Yeah, the radius will be, you know, of course, the diameter is given to us as 12, so that will be 6. I guess they didn't really give us units of measurement here. So pi r square would be pi times 6 squared. Okay, and then that's where you multiply by pi and you're rounding it to 1 decimal place. Okay, so this is where, since this is our intermediate step and this is not our final answer, this is where we will need to be careful because we actually don't want to round our answer at this stage. And this is, they didn't really tell us what the unit is, so we'll just say square units. And then to calculate the volume, that's the 1/3 area times height. Again, just to show you that very quickly. So 1/3 area times height. 1/3. So what I would recommend for these types of questions where the area is not your final answer, but an intermediate step, use this for your area calculation. So that way, you know, you're not having to worry about approximations. And then height, of course, is given to us as 6 units. And then you can calculate what the volume of this cone will end up being. And for the volume, then you can do the rounding. That would be fine. So even if you try to use the decimal approximation for your area, make sure you keep all those decimals after the 113. Or like I said, you can also leave it at 36 pi, so you know you're not going to have to worry about any rounding errors. So what do you get for the volume for this? Alrighty, yeah, very good. 226 point, let's see, the raw answer is 1946711. So yeah, you can round it to 1 or 2 decimal places. And this is volume, so this should actually be cubic units, since they really didn't specifically tell us what the unit measurements are. Okay, yeah, Logan, very nice. All righty. So just depending on if they ask you 1 decimal places, 2 decimal places, 3 decimal places, you know, you can do your rounding accordingly. Okay, let's do an example with our pyramid over here. So I guess we'll pick number 10. And this one you can see, since they're telling you the two bottom sides for that base is 12 and 12, of course, then that tells us what about the shape for the base of this pyramid? What is that shape going to be? If your measurements are 12 by 12.
Square.
Yeah. So it's a square. And again, you want to start by finding the area for that base first. Yeah, very nice, Brendan. And remember, for the area of a square, you basically do side times side or side squared. So you're multiplying 12 by 12, which will give you again 144. And we don't know what those units are, so we'll just say square units. And in this case, of course, we don't have to worry about the rounding. So this number will be fine. And then for the volume of the pyramid, you've got 1/3 area times height. So that's 1/3 times 144. And then let's see, they're telling us the height here again is 6 units. So what do you think this volume would come out to be? Yeah, very good, Brendan, Roman, Logan. Yeah, 288, and this will be in terms of cubic units. So, again, you can see both the examples as far as the volume goes was the same thing. The only difference was what your base was going to be. And depending on that, you would have to change your area formula based on that. Let's actually see if we can pick another example here. So I kind of wanted to highlight like some of these shapes you are seeing over here, as you can see, are going to be a combination of a couple different shapes, right? So if you look at this example here, we've got a propane gas tank that we are looking at, and they're telling us, it basically consists of a cylinder, and then you have, a hemisphere at each end. And of course, a hemisphere is half of a sphere, hemi, and then a sphere, so half of a sphere. So again, they're saying find the volume of the tank if the overall length to the entire length, from one end to the other is going to be 10 feet, and the diameter of our cylinder is 4 feet. So as you can imagine, we need to separate this, so we will first need to find, if you take those hemispheres out, we will need to find the volume for the cylinder, and then we can find the volume for these hemispheres. So let's again move this guy over to our notebook here so we can do this. So like I said, let's break it up into the volume of the cylinder and volume of the hemisphere. Now we know the overall length is going to be 10 feet, and then the diameter is 4 feet. Okay, so what do you think we need to do here first? Because we need to figure out, if we're going to separate those hemispheres, we need to figure out what this distance is going to be, right? From the, I guess, the tip of the sphere, if you would, till, where we cut off our cylinder. So what will this distance be, between the two hemispheres? If they're telling you the diameter of the cylinder is 4 feet, how can we use that information to figure out what, half of that length for the sphere is going to be on each side? Because imagine if the cylinder was not there, if we take this whole portion out and just bring those half spheres together. What do we know about the diameter of the cylinder? And how can we use that to figure out the diameter of the circle if we put it all together?
Would the diameter of the hemisphere be half
Half of what, Logan?
of the diameter of the cylinder?
Of the cylinder, okay. So are you saying for the hemisphere or for the entire sphere?
The hemisphere.
The hemisphere, yeah. Because basically, guys, think about this. If this was, imagine this is a sphere and not a circle. So the idea is if you bring the two halves together, that's going to create an entire circle, or a sphere, actually, not a circle. So if the diameter of the cylinder is 4 feet, that means the diameter of your sphere is also going to be 4 feet. So if you break it up into half, that means each half is going to be 2 feet. So this distance here is actually going to be 2 feet long. And that means from the entire length of the propane tank, you will be subtracting the 2 feet from each end, which means you're getting rid of 4 feet total, which means your cylinder will actually have a length of 6 feet. Does that make sense? Yeah. Okay. So based on that, then we can calculate what the volume of the cylinder will be. And, of course, based on that, we can also calculate what the volume of, the hemispheres will be. And honestly, since you have two hemispheres, you can put it all together. Let me save this and clear this out so we can actually move over here. Okay. So we know we have two hemispheres, so you're doing twice the volume. So honestly, since there are two of these, that's basically, you can do the volume for just one single sphere, right? And the volume for a sphere, again, just to show you that formula, the volume for the sphere is 4/3 pi r cubed. Come on, buddy. So 4/3 pi, and then like I said, your diameter is 4, which means your radius is going to be 2. So what are we looking at as this area for our sphere over here? Sorry, volume, not area. Okay, Brandon, you ended up with 33.51032.164, and Logan, you said the same thing as him. Okay, 33. 510. Roman, same thing, okay? And again, this is in feet, and since this is a volume, that's going to be cubic feet. Alrighty, now let's talk about the cylinder. So for the cylinder, you can actually use the same, let's get in here because I don't think they gave us a specific formula for the volume, but basically we can use they didn't really give that to us in here. Can we not do area times height because we don't really have to do a factor of 1/2 or 1/3 because we don't have a cone or a pyramid or a sphere? Yeah, I think we should be able to do, and I will verify this while we're working here, but for the volume of a sphere, we should be able to do area times height. And, if you look at the formal, formal formula for this cylinder, because, the bottom of a cylinder is circular, that means you're taking the area of a square, which is going to be, pi r square, and then you just multiply that with the height. So that's basically, in the way our textbook is doing it, you're multiplying the area of the base with the height of the object. And so in this case, our base is a circle, pi r square h, which is, like I said, look at the formal definition and you'll see that's the volume of a cylinder. So obviously we know that the radius is again going to be 2 feet. So same calculation here. 2 feet for the radius, and then the height I think we had calculated as 6 feet after we removed 2 feet from each end. So that was a height of 6 feet. And so what are you looking at? Your volume for just the cylinder over here. And will this number be, I think it should be more than the sphere because you are getting a little bit of a longer length in there with your cylinder over there. Okay, let's see, Logan, you had 75 point 3982236. Roman, you've got the same thing and you just had one more decimal after that. Okay, so to this, to get the total propane tank volume, of course, we'll add the two parts, the two shapes together, and that will give you the volume for the entire propane tank over here. And of course, this will also be in cubic feet. So we'll just again round it to 2 decimal places since we don't really know what the rounding is going to be. So go ahead and get your total and then let's see what your total volume for the propane tank is. Okay, so share your answer with me whenever you're ready. Alrighty, so just as a raw answer, it came out to be 108.90854553. So yeah, when you're rounding it, very nice. So it looks like all three of you had that answer rounded up, and this will still be in cubic feet. So, the reason I like to do this example over here with the propane tank is because you can see, you don't have to have a specific formula for the volume of, a shape that looks like this propane tank. You can break it down into, okay, my center of the propane tank is going to be a cylinder. The two sides are basically forming, two halves of a sphere, a hemisphere. So I can put the two halves together, get a sphere from that, and then my cylinder from the center, and that will help you come up with the volume. So you will see some of these types of examples in your homework. So that's kind of how you want to try and break these down. So again, guys, I will be here for the afternoon. If you have any questions on homework, let me know. If not, I will see you guys on Monday morning. And remember, we are taking our chapters 5 and 8 exam on that day. Okay, so if you have any questions, you can stay back and ask me. And if not, I will see you guys on Monday morning. So have a great weekend, guys. Be careful. Take care. Yeah.